Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you join operations in query processing and optimization. So let's begin. The algorithm that you see here is known as the nested loop join algorithm, which is the most basic algorithm that can be applied to any database join query that you can write in SQL. So let's see how this algorithm works in practice. So suppose that you have written a join query between two tables, and let's call one of those tables R. So there's a relation R with rows tr1, tr2, and tr3. Here tr1, tr2, and tr3 are tuples, and then there's another table S with ts1, ts2, and ts3. These three are also tuples of relation S. Now, using these two tables, we are going to check the algorithm. And remember that when I say tr1, it is not one value, it is an entire row. So you need to remember that it is an entire row containing all the columns and one entire row, which gives you values for all the columns. Now, the first line of my algorithm says, for each tuple tr in R, do begin. So you're going to pick a tuple tr1 from the relation R, and then each time you're going to pick a new tuple. So first we are beginning with tr1, and we move to the next line, which says for each tuple ts in S, do begin. So that means you're going to pick one tuple at a time from the relation S. And so I've picked all three because I need to match all three with one tuple of R, and then I have to match all three with the second tuple of R because it's a nested for loop. Now the next line says to match these tuples with each other to see if they satisfy the join condition theta. Now this theta join condition could be anything. For example, you could be trying to match one column of R with another column of S. Or you could be trying to check if one column of R is greater than another column of S, and so on. So this condition could be anything. But let's just assume that I want to create a condition called equal to. So my condition is simple, where I am trying to match one column of TR with another column of TS. And if they match, then this is the result that I want to keep. Now, let us assume that out of all the three tuples in S, which are TS1, TS2, and TS3, out of these three, the only one that is matching is TS1. So that means TR1 is equal to TS1. And so I can put this into the result because it is matching, because that's what my next line says. It says that if they do match, then you add TR-TS pair into the result. And that's what I've done. I've added TS1 and TS1 into the TR1 and TS1 into the result. Now, at this point, the algorithm again goes back to the for each loop, the first one. And once again, it picks a tuple from R. So this time the tuple is going to be tr2. And once it is picked, then the next line of the algorithm would help us to pick all the tuples from S one by one. And then still next line is going to compare all tuples of S with tr2. And once again, the condition remains the same, which is equal to. Now, suppose tr2 does not really match with any of the tuples of S. Then in that case, we are not going to add anything into the resulting table. We are going to implement the next line, which is if they do add them to the result, only if they actually match. If they do not match, we don't have to do anything. Now the next tuple that we are going to pick is tr3 because we move back to the first line of our algorithm. And once again, we pick one tuple from R, and that tuple is tr3. And due to the next line that says pick every tuple from S one by one. So once again, we are going to take all the tuples from S, compare them with TR using the next line of the algorithm. And once again, we are doing an equal to comparison. So let's just suppose that TR3 is matching with TS3, but it's not matching with TS1 or TS2. Then in this case, once again, we are going to add TR3 and TS3 into the result through the next line of the algorithm. And now if you check the first line of the algorithm, there are no more tuples left in R to pick from. And that's why this is where the algorithm terminates and your result of the join operation is ready. Whatever tuples matched, they are present in the result. So this is the very basic join operation in a database management system. This algorithm requires no indices and it can be used regardless of what the join condition is. Because the condition mentioned in the algorithm is very general. It just says condition theta. So it could be any condition equal to, greater than, less than, or less than equal to, or greater than equal to. So it's very easy to implement it. And also, it does not require that any of your columns should have any indices. Like, we studied indices earlier in the videos that I did about storage strategies. So in those, we studied that there are B trees and B plus trees, and there are hashed indices. So all these indices are available, but even if you don't have these indices, you can still perform a nested loop join. And if you want to extend this algorithm to compute a natural join, it is pretty straightforward. We already did it a little while ago. All you need to do is that you need to add an extra step of deleting repeated attributes from the tuple tr.ts before adding it to the result. Because when we are performing a natural join, we expect to find two columns. We expect to find a column in each table that is having the same name. For example, you might have a column called ID in one table and a column called ID in another table. And you are taking or trying to take a natural join based on the ID column. So after taking the natural join, you would end up with two ID columns. That's why you need to make sure that you remove one of them since it's a duplicate column, and because they are going to be matched and the data in both the columns will be same anyway. So you can just remove one column, and that's all you need to do. Additionally, if you want to perform a natural join using this same algorithm. Now let's see another algorithm. This algorithm is known as the block nested loop join, and it looks like this. So here you can see that instead of working with the tables directly, we are working with each block of a table. A block of a table means the part of the table that is stored in the memory, which is divided in blocks. So if you have a really large table, which is what happens in practice in SQL databases, you have really large tables, and these tables cannot be stored fully in one single block of memory, and it has to be divided into several blocks of memory in order to be stored. And once it is stored, if you want to read that table, and suppose that table took 10 blocks of memory, then you have to bring all 10 blocks into your main memory to be able to read that table. Now you can imagine what happens in your normal loop join algorithm. You would have to bring each block several times because you are trying to match one row of one table with all the rows of the second table. And to read all the rows of the second table, you have to bring all the blocks from the memory several times. So to avoid this, we use a block nested loop join. You can see the algorithm. There's a significant change because we added two more extra loops here. So in this, it's a variant of a nested loop join where every block of the inner relation is paired with every block of the outer relation. So this is what a nested loop join does, and a block nested loop join is slightly different from it. Here, each pair of blocks Within each pair of blocks, every tuple in one block is paired with every tuple in the other block to generate all pairs of tuples. So at one time, you're just reading two blocks from the memory, one block from relation R and one block from relation S. And then as before, all pairs of tuples that satisfy the join condition, they are all added to the result. So instead of applying it to relation R and relation S, we apply the algorithm to one block of R and one block of S. And then the same algorithm is applied. If the pairs match, then they are added to the result. The primary difference in cost between the block nested loop join and the basic nested loop join is that in the worst case, each block in the inner relation S is read only once for each block in the outer relation, instead of once for each tuple in the outer relation. So like I mentioned before, this algorithm provides you a much better way of performing loop join, because when you use a basic loop join, then you have to match each and every block of R with each and every block of S, and that takes a lot of time and a lot of cost, because you have to read a lot of data, a lot of blocks again and again from the secondary memory. But when you do a block nested loop join, you don't have to read all the blocks of R again and again. You only have to read all blocks of S. So this is how this algorithm works in a better manner. And that's it for this video. I'll see you in the next one. Thank you for watching.